In today's video, I will be explaining how to solve the problem hidden password. So in this problem, we're given a string and we need to find the smallest string rotation of this string. So this cannot be solved by just using brute force because the constraint for this is 100,000 and you cannot solve this in O1 square time. So we can use an algorithm called Boost's algorithm, and that will solve this in O(n) time. So what the logic behind this algorithm is that we basically want to use pattern matching to skip a few of the words that we've already seen, or a few of the letters in front of the string that we've already seen. And this may seem confusing, but this will become more understandable if you know a KMP algorithm. And that algorithm is used for pattern searching. So basically, if you're given a string and a pattern that you're looking for, you want to find where that pattern appears inside this main string, and that we can store a few informations about this pattern that will help us go faster when we are looking at the whole string. So I will explain this briefly. What we need to store at first is the length of the longest prefix that is also a suffix. So the longest prefix that is also a suffix is basically, for example, here, if we're looking at this string AAA, and also for the longest prefix, you cannot choose the whole string, but a few sections of the string. So here, if we're looking at these three A's, the longest prefix will be this, and also it's the longest suffix because this is the suffix, which is AA, and the prefix of this three letters is also AA. And this is the same applies for the four letters. For example, if we have AAAA, here the longest will be the three A's in front of us and the three A's at the end of this. So we have to store the information for each of these substrings, or each of these prefixes of the string. So first we'll store the longest prefix that's also a suffix for this string prefix A. And since we cannot choose any prefix that is that has the same length as the whole string, this will have the value of 0 because we cannot have a longest prefix that's also suffix without choosing the whole string. And then when we're looking at the two-letter string, we have AA. So this longest prefix that's a suffix will be A, and that has a length of 1 because A is the prefix of this and also the suffix. And this, as I said, this is the same for this 3A's, 4A's. And then for these two B's, if we include them in the prefix of this string, we will this will both have the value of 0 because there are no prefixes that are the same as the suffix. So after we store those informations, we can search through the string and maintain two pointers for each of these, the main string and the pattern string. So every time they match, we just move both of these forward ones. So first here, we're looking at A and A. Since they both match, we move both of the pointers forward. And then here, we're looking at B and A. So here, B and A doesn't match, so we will have to change our pattern pointer. We will see what happens if we move our pattern somewhere, if we move the pattern pointer somewhere. And to decide where I move to, we will consult the longest the length of the longest prefix that's also a suffix for the string that is 1 before this pointer. So our string that's 1 before this pointer will just be A, and as we've calculated, the longest prefix that's also a suffix for this letter A is just 0. So that will tell us the position of this pointer. And so our pointer will be reset here to 0, and we compare it with the pointer for our main string again. They're still not the same, but here we cannot decrease this anymore because this is already the smallest position of this pattern string, so we should increase our main string pointer by 1. And now we're looking at these two. The two A's match, so we move both of the pointers forward. Both still two A's, they still match, so we move them forward again. And then here, the D and A, they don't match, so we should consult our length of longest prefix that's also suffix again for the string that's 1 before our current pointer of this pattern. So the prefix for this pattern, with the pointer that we're currently looking at will be AA, these two A's, and so here the longest prefix that's also a suffix will be 1. We'll have a length of 1 because here it's a A and A. So we should change our index to 1 and then try what happens now. So here we would look at this index again. So we're looking at the 1's index before we're looking at the 0's index. This way we can skip this index because we know that this index definitely matches with this string. So here, this is why it helps us, because if we have the same, if the prefix is also the same as the suffix, and so before our pointer was here at this third A. So if this prefix A is also the suffix of our previous string, this means that we've definitely encountered this A somewhere in our pattern previous to our current letter, and that is correct because we've since our pointer for our pattern is already here. This means that those two letters definitely matched inside our main string along with the main string pointer. So that means we can skip the first letter because it's a suffix of this last letter as well. It's because these two are the same the prefix and the suffix. We can skip those prefixes because the suffix is already visited and we can change our prefix to that suffix. And this might sound a bit confusing, but if you try out a few more examples on your own or just type out a few of these patterns or strings and try that. So here, as I said, we are going back to this 1 index. We check, still not the same. And then we look at the longest prefix that's also a suffix with this current index. Since we're at just 1 letter now, it would just be 0. And then we compare again, still not the same. But here we cannot decrease our index for the pattern string anymore. So we should increase this pointer for the main string. And we look at this again. And they do indeed match as A and A. So we increase again and check these, and this A and B don't match, so we look at the longest prefix that's also a suffix for our current index as a pattern, and that's again equal to 0. We compare that again, still not equal, and now we look at this. So here we would find these two are equal, so we'll move forward. Okay, so here we move this pointer forward and move this forward. Still the same, we move this forward and move this forward, and they're not the same. And then this will just keep on going, and so here every time we're either increasing the pointer for the main string, or moving the pointer for the or checking the pointer for this pattern string. So this will take us linear time. So the time will be O, the length of this main string plus the length of this pattern string. And this is basically similar for our current string rotation. We're also looking at matching indexes. This way we can skip some of the locations that we need to compare. And this is what this A does. So here, first I will append this string that we read to itself, because then we're using some additions here, and this way we can avoid using modular. Then we're going to get the length of our current position. So this position will determine the splitting point of the string. For example, here, any splitting point that you choose, you will take the substring of whatever is on that side, and then so we will take the substring of this letter as the splitting point, including, and then also the all the way to the right, and then we will take the substring of whatever is on the left of this of the splitting point, and we will append the left side of this to the right side. For example, here, if our current splitting point is at this A, then we will take the left side of this A, which is AL, and append it to the end. And so this will give us one of the strings, which is this one, ABA, LAAL, because the ending AL is appended to this side. So we can think of this as a splitting point. First, I will choose the splitting point as 0 because we can change that later on using this for loop. So for every of these splitting points, we will do basically finding the longest prefix that's also a suffix that matches for the current string. And so we want to find the longest prefix that's also a suffix with a length of this I minus answer, because I minus answer gives us the distance between these between the current string, between our current point to the answer index. So we need to minus 1 because similar to what we just described here, we're looking at the prefix before this current pointer. So we want to get whatever is before this current pointer. That's why we have to minus 1. And here this distance basically represents which position of the answer string this index is pointing to. And then we will, so everything here I will first set to a -1 just to make sure we can stop. So while our current position is not, what is the length, the longest length of the prefix that's also suffix for a substring of this length. And so while it's not -1, and also the string, the letter that we're currently looking at, this SI, our splitting point character, if it's not equal to the answer plus our current length plus 1, so we're basically comparing this. So for example here, what this basically means is that we're basically comparing this current position in the main index, and so we can think of this as the position in the main string, and this as our current position in the pattern. So while the position in the pattern is not equal to the main string, we should compare these two. If the position of this current character is smaller than this character that we're looking at in the answer, and we can think of this I as also in the same position as this current answer plus p, or just have this position p plus 1. So if it's smaller than that, then our answer should be set to this, because this way we can have a smaller string than the previous answer. And what this does is basically we get the length of this current string, because we can think of I as one of these positions inside our current rotation string. And then we want to get the that minus the p, because we're getting whatever is in the beginning of this current string. Then we will set this p to the longest prefix that's also a suffix of this p with this length p. So then we can always decrease the p every time, and then we will be able to check for the smallest one until we reach a letter that actually matches. Because if they match, then we don't have to compare anything anymore, because since this is the longest prefix that's also a suffix, if they match, this means that whatever is in front, whatever is on the left of this current index that we're looking at will also match the other ones, so we don't have to look at the rest anymore. Or another case is when we reach all the way to the end with none of the letters equaling to any of the letters inside our main string. So if none of them are equal to this current letter that we're looking at, we should compare our current letter with the beginning index of our main string. And we can think of the beginning index as also the splitting point. So at first we will just have the beginning index at 0. We'll compare that as our index. So then if our current letter is smaller than that, this means that we should set this current rotation to our answer, because this way our first letter is already smaller than the first letter in our current answer index. So then here we will also set this to -1. And what this means is that anything with the length of this will definitely not be equal to, will definitely not have any longest prefix that's also a suffix, because here we know we've already checked everything, and p is still and p is equal to -1 already. This means that none of the letters that we checked already, so none of these matches, and also the final one doesn't match either. So all of these will not be equal to any one of each other. So we should set this to -1. Otherwise, if p is not equal to -1, or our current index for the s is equal to the first index in our answer string, then this way we can set any substring with this length of I minus our current answer index to p plus 1. And p plus 1 is basically the position of where our current, so p plus 1 is the position where we found a matching letter for the main string and the pattern string. And so in that case, we will set this longest prefix to p plus 1 because the previous ones already matched since this current string is equal to that string inside our answer string. So we should set this to p plus 1, and next time we'll be able to skip those p letters and compare the p plus 1 letter. And so basically this is sort of similar to this KMP algorithm, but here every time we're updating the longest prefix, that's also a suffix. And so this will keep on going, and every time we see something that's less than our current letter inside the string, we will set our answer to that. So finally, we'll loop through all the way to n-1. Then we can print out our final answer, which is the index of the smallest string rotation.